Our last topic is exponent properties. This one is also a very brand new topic. You may have not seen anything like this in 7th grade, so please email me if you have any questions. We are going to start with the terminology, and the first thing I want you to notice is I gave you the expression of 3 to the 4th power. This, in general, is called a power. The base of this power is 3, the base of it. And the exponent is 4, right there as the superscript. The term power may also be referred to as the exponents. So you can hear that 3 to the power of 4, or you can hear 3 to the exponents of 4. So let's label all of the parts to this. In general, if you have some number raised to a power, this whole thing is called a power. The x is your base, and the 3 is your exponents. All right, so looking at the power, a raised to the power of 4, this time my base is a. My exponent in the exponent part is 4. We write this out in the expanded form as a times a times a times a, because a raised to the power of 4 means I want a 4 times. My next one, my power is y. My base to this power is y, and if you have nothing here, let's put a little star next to it. No exponent number, notice nothing's up in the exponents, means that it is an understood one. So the exponent to just y is 1. Meaning my expanded form, I want y written 1 time, and that is the only part you can do for the expansion. All right, we've got a couple properties to learn that we're going to practice some problems with. Our first properties that we're going to learn are the multiplication properties. The multiplication properties, the first one is product of powers. To multiply powers, with the same base, we are going to add the exponents. Let me show you what this means algebraically. Let a, m, and n be real numbers. Then I'm going to use a as my base raised to the power of m. Multiplied 2, because we are multiplying powers, with the same base, so I'm going to write the same base of a, but this time I'm going to raise this one to the power of n. Simplifying these, since they have the same base, I'm going to add the exponents. So my base stays as a, and my exponents become m plus n. Once we actually have real numbers here, we will add those numbers together. For example, our number 1. Our first problem reads as 3 squared times 3 cubed. Notice we do have the same base. That means we're going to add the exponents. The base stays the same as 3, and my exponents, which are 2 and 3, we're going to add these together. So I'm going to rewrite this as 3 raised to the 2 plus 3. This simplifies to 3 raised to the power of 5, which we will simplify some of these, but I just want to show you the rules for it right now. Number 2. We have here negative 2 squared times negative 2. Now there is no exponent here in this problem, which means it has an understood exponent of 1. Negative 2 is my same base, so I'm going to keep negative 2, and my exponents are 2 and 1. So we can write this as negative 2 raised to the power of 3. And there is simplified. Number 3, x squared times x to the 6 times x. Notice here we have x's all as the same base. So I'm going to write this as x. I'm going to add all my exponents up, 2 plus 6 plus this understood 1. So my power becomes x raised to the power of 9. My last problem here looks slightly different because I've got some extra numbers here multiplied. You can still multiply. If I have 3a to the 4th times negative 2a to the 10th, I'm going to rearrange this and just rewrite it as 3 times negative 2, my whole numbers out front, and then put my same bases to the outside, times a to the 4th times a to the 10th. All I've done is rearrange my multiplication. 3 times negative 2 is negative 6. And the last thing I'm going to do here with same base, I'm going to add my exponents. So this becomes a raised to the 14th. And I am fully simplified. Okay, your next problem. We have our next property as power of a power property. Power of a power says power raised to a power. We are going to multiply the exponents. So for this one, I have a, m, and n for our real numbers again. If I had the base a raised to the power of m and raised to another power of n, I'm going to multiply the exponents as a raised to m times n. When we have actual numbers here, we will multiply those out. So for example, number 1 states 3 squared raised to the 2nd power. It's got a little blurry, I'm trying to make it a little more clear. There we go. So 3 is my base, and I have it raised to the 2nd power and raised to the 2nd power again. So this means I'm going to multiply those powers. This will simplify to 3 raised to the 4th power. The next one, I have y raised to the 5th raised to the 4th. So I have y as my base raised to the 5 times 4, which simplifies to y to the 20th. We have nothing really new for the other problems, so I want you to try pausing the video and practice 3 and 4. Okay, number 3. -3 was my base, and it was raised to the power of 2 and raised to the power of 2 again. I'm going to keep my base of -3 inside that parentheses and raise it to the 2 times 2, which gives me -3 in parentheses raised to the power of 4. Make sure if this starts in parentheses that your final answer ends in parentheses. In just a moment, we'll get to actually simplifying these. The last problem, I had a raised to the 2 raised to the 3rd power. So this became a raised to the 2 times 3, or final a raised to the 6th power. All right, our last multiplication property is power of a product. Power of a product we are going to first distribute the exponents. Then multiply. We'll talk about why that's our steps. So algebraically, I'm going to start with a, b, and m. If I had in parentheses a times b, all raised to the m power. When I distribute this one, notice there's no exponent on a or b. However, since there's no exponent present, these do have understood ones. So if I have power raised to something multiplied or a product, the first thing I do is distribute the m to both of those. Then the reason we multiply is because now this is power of a power. And like we just learned in the previous thing, any power raised to another power, we are going to multiply those exponents. So this simplifies to a raised to the 1 times m times b raised to the 1 times m. Well, 1 times m is just m. So this becomes a to the power of m and b to the power of m. We cannot simplify this further because a and b are not the same bases like we had in our first product of a power. So this will be our final answer. Let's practice that. For these, we are going to fully, my apologies. For these, we are going to fully, keeps taking a picture there, fully simplify them. Press the wrong button to try to clear this up. Okay, so the first thing I have is 3x squared. So 3 and x do not have exponents on them, which means they both have the understood ones. I'm going to distribute this power of 2 to both of those bases. So this becomes 3 raised to the 1 times 2 and x to the 1 times 2. Simplifying that, I get 3 squared and x squared. Now, we are going to fully simplify these, and I want you to fully simplify them on your homework today. 3 squared is 3 expanded form 3 times 3, or 9. So this becomes 9x squared. This is fully simplified now. If you can simplify one of your numbers, go ahead and simplify it out. Okay, the next problem. We have 2xy to the 5th power cubed. This time I have 3 things multiplied together. So I need to make sure that this cubed goes to all 3 terms. The power of 2 is 1, and the power of x is 1, and the power of y is 5. So I'm going to distribute this 3 to the 2, to the x, and to the y. This becomes 2 to the power of 1 times 3, x to the power of 1 times 3, and y to the power of 5 times 3. So now simplifying this, I have 2 cubed, x cubed, and y to the 15th. I can simplify this number a little bit further. Expanded form of 2 cubed is 2 times 2 times 2, or 8. 2 times 2 is 4, times another 2 is 8. So 2 cubed gives me a value of 8. And then I have x cubed y to the 15th. This is fully simplified. Number 3, I have negative 3x squared. Notice my negative 3 and my x inside parentheses. The power of negative 3 is 1, and the power of x is 1. So when I distribute my 2 to both of those, I'm going to keep this negative 3 inside parentheses, just like I kept it inside parentheses here. So I have negative 3 raised to the 1 times 2, and x raised to the 1 times 2. The reason this needs parentheses is because it's a negative number. This becomes negative 3 to the power of 2 and x to the power of 2. Negative 3 expanded is negative 3 times negative 3. The negatives will cancel, and this gives me a positive 9. So I have 9x squared. Different from that one is number 4, because my negative sign is on the outside. So when I distribute this power of 2 to 3 and x, which have exponents of 1, I'm going to distribute to the 3 and distribute to the x, and I'm going to leave this negative sign, this time on the outside. Because 3 is positive, I don't need parentheses. So I have 3 raised to the 1 times 2. And then I have x to the 1 times 2. I'm going to keep my negative sign on the outside, and I get 3 squared and x squared. 3 squared is also 3 times 3 like we've done before, which is 9. But this one has a negative sign on the outside. Negative 9x squared. I just wanted you to see a difference between the negative on the inside of an exponent and the negative on the outside of the exponents. Here, the negative sign got pulled into the squared. And here, the negative sign stayed on the outside as if it were just negative 1 times this entire quantity. So this quantity, like we did in previous problem, I'm going to move this over to number 1, was just that 3x squared, and we got 9x squared. So negative 1 times 9x squared is negative 9x squared. That's how the negative sign this time stayed in the answer. All right, so let's flip it to the back side. We're moving on to our division properties. Our first division property is quotient of powers property. To divide powers, with same base, we are going to subtract the exponents. Let a, m, and n be real numbers and a not equal to 0 because we are going to be dividing. We don't want to divide by 0. Then a raised to the power of m divided by a raised to the power of n, I keep that same base of a and I subtract the exponents. M minus n. When we get to actually simplifying these, we will simplify those problems out. So our first problem reads -3 to the 5th divided by -3 to the 3rd. I'm going to keep that same base of -3. And I'm going to subtract my exponents. So I have 5 minus 3. This simplifies to -3 raised to the power of 2. And on your homework today, you will simplify that, just like we did on the front side, to +9. Right here, I just want to show you all of your rules. Our next problem looks a little bit funkier. We have x to the 6 times 1 over x. Well, this is also just a basic division problem. We have this x to the 6 technically in the numerator, and we have an x in the denominator. So I can actually rewrite this problem by multiplying the top as x to the 6 and multiplying the bottom as x. So now my problem becomes x as my base. This has a power of 6. The bottom, I'm going to write in here your power of 1 if there's nothing written. So 6 minus 1, which simplifies to x raised to the power of 5. All right, number 3. This time you have some same base with exponents, and you also have here some whole numbers. You can separate this problem by first simplifying your whole numbers, just like the previous. Let me move back to our multiplication one. We separated our multiplication and we separate our same base. We multiplied first and then applied the power rule. So here I'm going to first divide. 2 over 4 gives me 1 over 2, or 1/2. My x values, x to the 5th and x squared, I'm going to write as x to the 5 minus 2. So this gives me 1/2 x cubed. This is one way of writing this problem. Or we can actually write this as x cubed over 2. Because this x cubed here is actually in the numerator from that 5 minus 2, and this 1 is understood as a coefficient. So this is another option of how you could write your answer. Same as 1/2 x cubed. Last problem, number 4. My base this time is 3. So I'm going to keep my base of 3. I'm going to raise it to the exponents of 3 minus 2, which gives me 3 raised to the first power. But 3 raised to the first power, you can always make this disappear as the understood 1. So this is just 3. All right, our next property is power of a quotient property. Power of a quotient we will first distribute the exponents. Then multiply. This works very similar to power of a product. Let a, b, and m be real numbers, and this time b will not equal 0 since we're going to put b in the denominator. So I have a divided by b. all raised to the power of m. These both have understood 1s as the exponents. I want to first distribute the exponents to both the numerator and the denominator. And then we multiply, because this is written as a raised to 1 raised to m, and we remember from our previous power to a power, we multiply the exponents. So this becomes a raised to the 1 times m divided by b raised to the 1 times m. Simplifying that, I get a to the m divided by b to the m. I cannot simplify this one further because even though this is a division problem, I need the same base. This base is a, this base is b, and I cannot actually combine the exponents. So this is fully simplified. So let's practice this problem. The first problem is 2/3 squared. So the exponent of 2 is 1 and the exponent of 3 is 1. I'm going to distribute my power to both of those. And I get 2 raised to the 1 times 2 with that multiplication divided by 3 to the 1 times 2. Simplifying this, I get 2 to the second power and 3 to the second power. On homework, you will be fully simplifying this, so you can either just see the example here, or you can see that 2 squared is 4 and 3 squared is 9. This is the fully simplified of that answer. Okay, our next problem is 1 over x raised to the 5th power. So I'm going to first distribute my 5th power to both the 1 and the x. Both of these have exponents of 1. So I'm going to distribute my power of 5 and my power of 5. So this becomes 1 to the 1 times 5 and x to the 1 times 5, which simplifies to 1 to the 5th power and x to the 5th power. Now 1 to the 5th power is just 1 times 1 times 1 times 1 times 1, which is equal to 1 and divided by x to the 5th power. So I am going to simplify that 1 to the 5th. All right, number 3. Try this problem out on your own if you would like. Try it by fully simplifying to its simplified terms. Okay, both of these had powers of 1, so I distributed the 3 to both the -3 and the +2. Notice, since this was negative, I did put it inside parentheses. This one won't be affected as much, but it is in good practice to always keep negative numbers inside parentheses. The next thing I did is I simplified the 1 times 3 and 1 times 3. So I had -3 cubed over 2 cubed. -3 cubed expanded is -3, -3, -3. And 2 cubed is 2 times 2 times 2. So the first part I got -27, and on the bottom I got 8. So this is -27 over 8. All right, last problem for power of a quotient. I've got 3 terms in this problem. The exponent to 3 is a 1. I'm going to first distribute each of these powers to each of the terms. So I have 3 raised to the 1 times 2, x raised to the 3 times 2, and on bottom in denominator I have y raised to the 6 times 2. This will simplify to 3 squared x to the 6 divided by y to the 12th. I can simplify 3 squared, just like you will on homework, to 9, x to the 6 divided by y to the 12th. Notice I cannot do anything else with 9, x, or y because all of these have different bases. So this problem is done. All right. Our next property is called zero property. Any non-zero base raised to 0 equals 1. Let's see what this is. Let A be a non-zero real number. So A raised to the power of 0 equals 1. Now the reason we cannot have A be a zero number, because if I had 0 raised to the 0 power, this is actually undefined. We cannot raise 0 to the 0 power, but we can raise any other number to 0 and it equals 1. For example, and you can check these in your calculator. Negative 10 raised to the 0 power means I have 0 negative 10s. So to the 0 power, this equals 1. That is our final answer. Now this one's slightly different. I have 6 times x to the 0 power, which means I have 6 times x to the 0 power alone is just 1. So this equals 6. Number 7. Oops, I kind of had these mislabeled a little bit. It's actually our third problem. 2x squared y to the 0 power. Now, when you have a problem like this, you can jump straight to what the answer is. But I want to show you all why this is equal to what it is. Now, this is actually a power to a product. My 2 has a power of 1, my x has a power of 2, and my y has a power of 1. Just like we did before, I'm going to distribute my power to all 3 terms, which gives me 2 raised to the 1 times 0, x to the 2 times 0, and y to the 1 times 0, which simplifies to 2, 1 times 0 is 0, 2 times 0 is 0, and 1 times 0 is 0. Well, we just learned any number raised to 0 is 1. So 2 to the 0 is 1, x to the 0 is 1, and y to the 0 is 1. 1 times 1 times 1 equals 1. Or you could see this entire thing raised to the power of 0 and jump straight to the fact that anything raised to the 0 power equals 1. Our last one on here is negative 2 to the 0 power. Now notice the difference between the first problem we had, as negative 10 was inside parentheses, and this one is not. So this works the same way as leaving this negative sign on the outside as a negative 1. So negative 1 times 2 to the 0 power, which is negative 2 to the 0 power, is negative 1 times 1, or negative 1. So if you have a number attached to the outside, it ends up being that number, because anything else attached to 0 gives you a 1 answer. But if the entire problem is inside parentheses raised to 0 power, your final answer is positive 1. Our last property is the negative power property. Negative powers must be written as the reciprocal. If you didn't already know what the word reciprocal means, we used this in the previous problem, in previous worksheets actually. If we had the reciprocal of 2/3, the reciprocal would be 3/2. So it is the opposite, flipping a fraction. We use this with negative power property. Let a be a non-zero real number, because we're going to have this in the denominator. So if I'm going to start with a raised to the negative n, negative powers must be written as the reciprocal. So when I get to write this as the reciprocal, which this is technically a over 1, I reciprocate that to 1 over a. And that power, the negative exponents, becomes positive. We can do this the other way. Our other one is 1 over a to the negative n. I do not want this negative power, so I must write it as the reciprocal. So this time I'm going to bring a to the top to the power of n, and you can put that over 1, or just write it as a to the n. This one's a little more confusing, and we will definitely get into the why on all of these properties when we learn them in algebra. But just for now, I want you to practice this topic. So the first problem, trying to make this a little more clear, 2 raised to the negative 3. I have to write this as the reciprocal. Well, 2's reciprocal is written as 1/2, because this is technically 2 over 1. So if I'm going to write 2 to the negative 3 as a reciprocal, I can write this as 1 over 2 cubed. When it becomes the reciprocal, that negative exponent disappears, which 2 cubed, we know, is 2 times 2 times 2, or 8. So this 2 to the negative 3 is actually 1/8. Our next problem, we have negative 2x to the negative 4. This is the only part with a negative exponent. We can have negative numbers, we just can't have negative powers. So I'm going to write this as negative 2, because that's okay where it's at. And I'm going to reciprocate x to the negative 4 as 1 over x to the 4th. I'm going to simplify this problem by multiplying that top part as negative 2x to the 4th. So basically what I've done is I've taken this in the numerator and I've dropped it down to the denominator, and it becomes a positive exponent. Number 3, I have 1 over 2x to the negative 3, which is similar to our second concept. If it's negative in the denominator, we must reciprocate it up to the numerator. So this whole piece actually needs to go to the numerator, and this becomes 2x to the positive 3, and you can put that over 1, or you can leave it just as 2x cubed. This is power of a product. Both of them have powers of 1. So I'm going to simplify this all the way down by distributing. And I have 2 to the 1 times 3 and x to the 1 times 3, which becomes 2 cubed x cubed. 2 cubed is 2 times 2 times 2, which is 8x cubed. So this is fully simplified. Our last problem here, I'm going to show you why we can use, or why we need to learn and use, these negative exponents. Notice our last problem is a division problem. x to the 4th divided by x to the 6th. Going back up to our division properties, to divide powers with same base, we subtract the exponents. So like we did here, x to the 6 over x to the 1, 6 minus 1 equals 5. So I'm going to apply that same rule here with our last problem. I have x to the 4th divided by x to the 6th. So x to the 4 minus 6. 4 minus 6 gives me x to the negative 2. But I can't have negative exponents left in my problem. So I have to reciprocate this, and it's similar to this first concept. So I've got to put this in the denominator. Since there's nothing in the denominator right now, the numerator just becomes 1. And this becomes 1 divided by x squared. I will be posting some more videos on this if you would like to learn a couple more concepts or see some more practice problems. This one's a brand new topic, so I understand that this one's going to be a little more frustrating. What I would do first is I would go back to all of our properties. I've put boxes around each of the properties with our multiplication, our 3 of them. And then you also have your division properties. We had 2 of them. We had our 0 property and our negative property. What I would do with all these properties is I would go through and I would memorize them and understand what they're actually asking me to do, and then I would try the homework. Please email me if you have any questions about any of those homework pieces. On Friday is your test. I want you to try this test without notes and without homework. You may use a calculator on that test, and you may work the problems out on a scrap sheet of paper. This test is just for your knowledge to see what you learned through this whole week. Don't worry about it if you're not really certain on how to answer one of the problems. I hope you've enjoyed this course.